All right, ladies and gentlemen, we're going to look at here some integration by partial fraction decomposition. So, for example, again, just like yesterday, as I kind of introduced this to you guys already, we have x plus 4 here times 2x minus 1. And you have here a rational function. Okay, so this is already factored though. So you might say, okay, good, we already have it factored. If it's factored for you, then, be happy about that. So what I'm going to focus on here is that process known as partial fraction decomposition. So remember, what was that? The partial fraction decomposition, what this was, or what this is, you're writing a rational function as a sum and difference, difference of simpler rational functions. They're going to be simpler. You're going to see what we're talking about, okay? And instead of integrating this, we're going to integrate the simpler, rational functions. Okay, so what I want to recall here is two things. This is called a linear factor, right? You say, why is that linear? The power of x is 1. This is a second linear what? Factor. Power is 1. So we call this distinct what? Linear factors. So this is like thought of also as case 1, just in case. Case 1, distinct linear factors. Now, here's the thing. A over x plus 4. You're going to take that first linear factor and you're going to keep that as a denominator, but the numerator is a. And then for the second linear factor, call that b now. And so I want you guys to see that. So it doesn't matter if you have 3 linear factors, then that would be a c, Hopefully you don't. But we call this distinct linear factors, meaning different factors. So we're going to look at the different cases for partial fraction decomposition. Now, a and b, that's the whole idea. We need to find a constant a and a constant what? B. Those are constants, capital A, capital B. And so you might say to me, okay, well, how do you actually do that? We're going to need that equation we got yesterday. You guys remember that equation? How did we get the equation where we can find the constants A and B for distinct linear factors? Do you guys remember? You focus on the right-hand side here, all right? And what you do is add your rationals. Remember that little procedure I gave you guys, that shortcut? Add the rationals. You say, well, what does that mean? That's a times 2x minus 1 plus b times x plus 4 on the right side, okay? And then you're going to multiply the denominators together. X plus 4, 2x minus 1. And that's on the right side. On the left side, what do you have? You have this. X plus 4, 2x minus 1. So what piece of logic do you guys use now? Do you guys notice? You have the same denominators. What does that force you to conclude then? If you have equal fractions here, okay, with the same denominators, what does that mean about your numerators? Do you guys know? Here's the two numerators. You know what this means? They have to be equal. So that's saying x is a 2x minus 1 plus b x plus 4. Okay? Now, in this situation, this is kind of the nicest situation to be in. And you might say, why is that a very nice situation? Do you guys know why that's so nice? Because now we can actually find the constants A and B pretty simple. Okay, we're going to take two cases again here, just like yesterday. You see this over here, x plus 4? I'm going to let x be negative 4. Okay, so wherever there's an x, replace it with negative 4. Do you guys know why I do that? Why did I do that? You see right on over here? Right? If x is negative 4, doesn't that term go away? That's the idea. So, on the left, negative 4 equals a 2 times negative 4 minus 1, and then that's going to be plus b times 0. I don't even have to write it down because I know that goes away. That's why I chose the value for x to be what? Negative 4. And then you get negative 4 equals a, isn't that negative 9, by the way? Double check. Okay, you guys okay with that? So now we get negative 4 is negative 9a. What does that mean about your value for a? A is going to be what? Isn't it a positive 4/9? And I'm not sure what color. Yeah, that's going to be orange or whatever this is. A is 4/9. You guys okay with that? So, ladies and gentlemen, once you get this equation, it's actually really simple now. What do you do here then? What are you going to let x be now? Right? We want to zero out that a term. What does x have to be now? 1/2? So we're going to let x be what now? 1/2. So wherever there's an x, replace it with a 1/2, okay? And what does that give you now? 1/2 equals, well, this portion here, the whole reason you did that is so a could be 0. Now, what do you get? B times 1/2 plus 4. 1/2 is b times, do you guys know what 1/2 plus 4? Isn't that 9/2? Double check. I'm not really awake yet. 4.5, isn't that 9/2? So what do you think that means? Right? Doesn't that mean 9b is 1, or that means b is 1/9? Okay, you guys okay with that? So the whole idea, ladies and gentlemen, is to replace A with what it is, B with what it is. What was A again? What was A? 4/9. So this is going to be what? 4/9. What was B? 1/9. Okay. So let's take a look. Here's what that means. Partial fraction decomposition. It means this is going to equal now 4/9 x plus 4 plus 1/9 2x minus 1. Okay? What you did was you accomplished what partial fraction decomposition is all about. So the more complicated fraction now is written as a what? Sum of two easier fractions. And all along, the idea was to really what? Integrate. Good. So, all right, use your properties of integration. Integral of a sum is sum of integrals. Integral of a constant times a function, pull out your constant. And this is what I'm saying. This is what you guys get. So now you have two integrals that are easier to integrate. Okay, so let's see, ladies and gentlemen, what's the integral? Notice again for both of these, by the way, you're going to have to use u sub for both. Is that true? And so by u sub, I'm going to get natural log absolute value of x plus 4 here, and here I'm going to get 1/2 natural log absolute value of 2x minus 1. Double check. Okay, double check here. 4/9 natural log x plus 4 plus 1/18 natural log 2x minus 1. Don't forget to add your constant, okay? And you're done. Okay, you guys okay with that? So what I'm going to share with you guys, these are what's called distinct linear factors. Different linear factors in the denominator. Okay, you guys, is that easy? All right, give you guys another example. And you have now x squared plus 2x minus 1. Everything over x cubed minus x. Take a look at that one. X cubed minus x. So what do you guys do here? You're supposed to factor, is that right? X squared minus 1, isn't this x? X plus 1, x minus 1? Okay? So you get x squared plus 2x minus 1 over x plus 1, x minus 1. So I'm going to say this again here. You got this term, this factor. The x is a factor. The what? X plus 1 is a factor. And then you have the what? X minus 1 as a factor. What would you guys say? Again, you're in what? Distinct. What does that mean? Different. Linear factors. There's 3 different linear factors now. How do you know they're linear? The highest power of the variable is what? 1. Okay. So what you do for every linear factor, put the constant a over that linear factor. So this is a over x plus a different constant over the next linear factor, okay, plus c over x minus 1. So I want you guys to know here, you have this is the x, this is the x plus 1, the x minus 1. So you have this distinct linear factor. And then, what do you say now? What do you guys have to do now? Do you guys know? You're supposed to add the right-hand side. You're supposed to add these terms. So we're going to do that. We're going to try to add these terms. What do you guys think? Add them. You know what you're going to end up with? First of all, as a denominator, you guys are going to have x plus 1, x minus 1. Is that right? You're going to have those factors if you try to do the LCM. And then this is going to be a x plus 1, x minus 1, plus bx, x minus 1, plus cx, x plus 1. And I put my equal sign over here. So again, notice here, x plus 1, x minus 1. I have fractions that are the same. What do you know about those numerators? Those numerators have to be what? Equal. Is that right? So what that says is x squared plus 2x minus 1 is the same as a x plus 1, x minus 1, plus bx, x minus 1, cx, x plus 1. Okay? You guys okay with that? Okay, you guys okay with that? Isn't that the exact same logic, but now you have 3 terms? All right. So how do we get the constants a, b, and c? We got to zero these terms out. Maybe I start systemically, right? So you say, what do you mean? Start here. You see this x plus 1? What do I let x be? If I let x be negative 1, okay, doesn't that zero out this term? You see what I'm saying? I just have to make sure every x is what? Negative 1, okay? Now, notice on the left side, you get what? Negative 1 squared, 2 times negative 1 minus 1. This is b times negative 1, negative 1 minus 1, c times negative 1, negative 1 plus 1. You know what's so nice? Even that term became 0. Well, that's even nicer. Okay, so on the left, I get 1 minus 2 minus 1 is b, negative 1, negative 2. And that's saying negative 2 is actually what? 2b, or it means b is negative 1. Okay, you guys okay with that? So, I mean, this is the process. And if I said to you now, go back to that original question here, okay? And I'm going to try to zero out over here. I'm going to use this value. What does x have to be to make this whole thing 0? Do you guys know? What does my x have to be now? Let that be 0. And if I do, isn't b times 0, 0? In fact, isn't c times 0, 0? This is actually a very nice question. This is nicer than you thought, okay? Because now we have what? 0 squared plus 2 times 0 minus 1 is a, 0 plus 1, 0 minus 1. So negative 1 will be what? What is this? A times 1 times negative 1, and that really means a is 1, okay? So to let you guys know, we're finding our constants. We're being systemic. Okay, you guys okay with that? This is what you do to get the constants. Okay. Let's be systemic again. Let's go through here now, ladies and gentlemen. What about, how do I get the next one, right? Go through it here. I'm not going to use x as 0. What do I have to use now? Oh, we already did x is negative 1. Is that true? So what do you think we should do now? I mean, I mean, we use that over here, is that right? So we already used those. Let's try to use what? Let me do this here. You guys see this here? I'm going to use x being what now? 1. Okay? Let me see what I get. The truth is, I can use any value. I can use x is 7. It just doesn't mean the right side gets 0 anywhere. I can use x is 4. I can use x is -2. It doesn't mean I can use any number. So if I use 1, I'm going to get some zeros here. Okay? You say, where do I get 0? I get 0 here if x is 1. Is that right? Maybe we can't use that one. X is 1. I'll get a 0 over here. Is that true? And I'll get C now. Okay, here's what I'll get. One squared plus 2 times 1 minus 1. Is that right? And then I get C times 1. That's 1 plus 1, because x is 1 here. Okay? All right. Okay, let's see what we get. 1 plus 2 minus 1 becomes 2c. That means 2 is 2c. What does it mean about c? C has to be what? Isn't c 1? There you go. So I got all my constants, ladies and gentlemen. A is 1, B is -1, C is 1. All right, A is what? A is 1, C is 1, B was -1. Is that true? Double check. I didn't write that down. So what I'm going to say to you guys, again, is this, okay? I'm going to copy it all again. Let me be careful. And now we're going to do what here? We're going to integrate. This will be dx. We're going to integrate. This will be dx. Okay, so this is now the integral of what? 1 over x minus 1 over x plus 1 plus 1 over x minus 1, okay? And again, integrals of sum and differences, you got 1 over x dx minus integral 1 over x plus 1 dx plus integral 1 over x minus 1 dx, okay? Are these easier to integrate? All right, what's this going to be? Remember, over here, you're going to use u sub. Over here, u sub. What do you get? Natural log absolute value of x minus natural log absolute value of x plus 1 plus natural log absolute value of x minus 1 plus that constant. And then, ladies and gentlemen, do you guys remember by properties of what? Logs? Natural log x over x plus 1 plus natural log over x plus, minus 1. So this would be natural log absolute value of x minus 1 over x plus 1 plus c. All right, ladies and gentlemen, easy peasy lemon what? Lemon squeezy. This is by properties of logs, the sum and difference properties. So as you guys know, this is the process you go for distinct linear what? Terms. Different linear terms. Okay? Anybody have any questions on that one? Distinct linear terms? All right, now, here's what I'm going to do here for you guys. This is thought of here as like case 2. That's when you introduce a quadratic factor. So when you have a quadratic factor, and I'll share with you guys what that even looks like to have a quadratic factor, but okay. X squared, and that's actually minus 5x plus 16. Well, I mean, here, I can do this better instead of, before going to the quadratic. Sorry, I apologize. Let's do a repeat linear. We should stick with the linear before we jump to quadratic. We're going to do a repeat linear. I'm going to share with you guys, what does that look like as a repeat linear? You have x squared minus 5x plus 16 over, here's a linear factor, 2x plus 1. Now, here's going to be the repeat linear. Okay? Let me share with you guys why we do it that way. That's a linear factor, is that right? It's linear. And then what is this over here? Isn't x minus 2 also linear? You guys with me on that? But why do you think they call it a repeat linear? This is repeat because the linear factor you have gets repeated twice. The power is 2. Okay? All right. Now, here's what I'm going to say. I think this is what your book says. It says something like this. Here's what you guys want to do. For every repeat linear factor, you have x, here's how they write it, ax plus b, I guess, to the nth power there. This is repeated n times. You're going to use as a denominator, this is for use. You're going to use this system. A1, A subscript 1, x B1, plus A2, A2x plus B2. Now it's squared. You're going to add that all the way up to AN. ANX plus BN to the nth power. Okay? See that nth power? Nth power. Now, what does that mean in this case? Here's what I'm saying. This is what this means in this for this question here. Right, you have x squared now you have what? 2x plus 1 x minus 2 squared. So this is for my first linear factor. Okay? This is a linear factor, so you're going to say a 2x plus 1. Okay? That's not repeated. But I'm going to put it down here. Now you're going to say, well, what about this x minus 2 that's repeated twice? Okay. This is what this means. Start with the x minus 2 to the first power, and then add x minus 2 to the what? Second power. X minus 2 to the first power, x minus 2 to the what? Second power. That's what they mean about using this criteria here. Okay, that's what they mean. But the question is, do I put A1 and A2? No, put the letters B and C. Okay, don't put like A1 and A2 as subscripts. Just use the regular letters. They're not going to give you 10, power 10, power 20, They're not going to give you that because it'll take too long. It's just, again, you got to find three constants, A, B, and C. Okay, you guys see the point? So you start with the power 1. That's what that means. Like if you had to put, do I start with 1? Yes. And increase power 2 all the way up to power n. They're not going to give you a large power. But this is in partial fraction decomposition. This is called repeat linear. Okay? They're both linear, but this is where it was repeated. It was repeated twice. Okay, x minus 2 times x minus 2. A repeat linear factor. And then again, you say, well, what do I do now? Well, you really add, ladies and gentlemen. You really add the right-hand side. And, when you do that, notice what you get as a denominator. You're going to get just the 2x plus 1 times x minus 2 squared. This is the LCM. Is that true? When you add rationals, that's the LCM. But now this will be a times x minus 2 squared plus b 2x plus 1 times an x minus 2 plus c now, just 2x plus 1, I think. Yes. Okay, now you say, what does that mean, Mr. Judge? Again, you have equal fractions with the same denominator. That means my what? Numerators have to be the same. So you have that x squared minus 5x plus 16 will equal a x minus 2 squared, b 2x plus 1 times x minus 2, c 2x plus 1. Okay? This is that equation you guys are going to use to get your constants a, b, and c here. Okay, so this is that equation. So now you might say, well, how would I do this now? Well, what I'm going to say is this. You're going to do the following to get your constants here, okay? I would say you're going to let x be 2. Let x be, you're going to let x be 2, x be negative 1/2, is that right? And then you say, I have another option. You can choose any value of x that you want. If I can choose 0, I would use 0. Okay, that's not going to make anything on the right-hand side become 0, but it's a nice number. Do you guys know what I'm talking about? So here's what's going to happen if you guys let x be these numbers. I'll tell you what you get for a. Okay, for the sake of time. A is going to be 3. Your b value is going to be negative 1. And then the c value is going to be 2. Okay? Three, negative 1, 2. So you go back up here and say, oh, 3, negative 1, 2. Okay? And what I'll do now is I'm going to do this. I'm going to say to you guys, I'm just going to use the right side and not write it all down. Because by now, it starts to be a lot to write. It's negative 1, and then this is just going to be 2. Okay, so I'm not going to write because there's a lot, a lot there. But anyway. All right, now, ladies and gentlemen, you now have really what again? By properties of integrals, I have what? I have one integral minus the second integral, okay, plus 2 times that third integral. U sub. What is this? U sub and U what? Sub. Okay, you got 3 integrals here. First integral, what's this? Second integral, and this is going to be the what? Third integral. What do you guys think? Is that okay? So for U sub, notice this integral here in orange. I'm going to put it in orange maybe, right? 1/2 natural log absolute value 2x plus 1. In green, well, that's just the natural log absolute value x plus 2. And then, what is this one in brown or gold? You say, I'm going to have to do the work here. Isn't u x plus x minus 2 and du is the same as dx? So that integral here is going to be 1 over u squared du, which is u to the minus 2 du, which is negative u to the negative 1. It's going to be plus that c, negative 1 over u, and u is x minus 2. So that's negative 1 over x minus 2, and we're going to have that constant there, okay? So this is that brown integral there. Let me write it next to it. Where to write it? All the way down here. Negative 1 over x minus 2. We're gonna have plus c, okay? And there's a constant 2 in front, so don't forget that. So let's deal with all the constants that we have. Constant 3. Oh, this is just negative 1. There's a 2. So let's write down the final answer, right? This will be 3/2 natural log absolute value to x plus 1, right? Minus the natural log absolute value of x plus 2. And then this is 2. This will be minus 2 over x minus 2 plus a constant c. Yes?
Isn't the second one the natural log of x minus 2 because it's repeated?
Oh, I'm sorry. That was a minus 2. I apologize. Thank you for being awake. I'm not awake. That is a minus. Thank you so much. That is a minus. Good job. Yes. And again, we could leave it like that, okay? All right, you guys okay with that? Repeat linear factors. And we can have an integral like this, 1 x squared x minus 1 squared dx, okay? Now, what I mean by repeat linear factors here, okay? Let's focus on this here. We can say this is x times x, x minus 1, x minus 1. Repeat linear. Why linear? Power 1, power 1, power 1, power 1, right? So we can look at it that way. So remember, for this first repeat linear, we're going to have 2. For the second repeat linear, we're going to have 2, okay? So let's write that down. This is 1 over x squared, x minus 1 squared. That is a over x, b over x squared, c over x minus 1, okay? And then it's going to be what? D over x minus 1 squared. So remember, you always start with 1, but you end where the highest power of that repeat linear factor is. Okay, so maybe you guys can see it with the colors there. Okay, so remember now, on the right-hand side, you're going to do your addition. Is that true? So you're going to add on the right-hand side. So you're going to get the same denominator as x squared, x minus 1 squared. So you're adding 4 rationals. So with the constant a, that'll be x, x minus 1 squared. Plus b, just x minus 1 squared. C, oh, we need a factor of x squared and another factor of x minus 1. And then D, that's just x squared here. Okay? So I don't know how you guys remember how to add rationals with that LCM. The LCM is x squared, x minus 1 squared. But the other constant terms, you know, you're going to have to do what? Write down the terms that are missing from the LCM, x squared, x minus 1 squared. Here's what I mean. This down here. LCM, LCM. And then what does that imply again? If the denominators are the same and this fraction's equal, that means 1 is ax, x minus 1 squared, b, x minus 1 squared, cx squared times an x minus 1 plus dx squared. Because that means your numerators have to be the same. So when I start to zero terms out, I can automatically see, let x be 0, that's 1. Okay, let x be 1. Okay. And then maybe something interesting happens. Yeah, let's try this out. Let's see what happens, ladies and gentlemen. Okay? If x is 0, on the left side you have 1. You're going to get b, 0 minus 1 squared, and that's it, I think. Is that true? That's when you say x is 0. So you're going to put a 0 here. This is gone. Put a 0 here. This is gone. Put a 0 here. This is gone. That means my b value is 1. Is that true? Okay. Now, if you let x be 1 now, one, 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 one. What happens when x is 1 now? All right, we get 1 equals, well, the A term is 0, the B term is 0, the C term is 0. That means D times 1 squared. Well, that just means D is what? 1. You guys okay with that? So I'm going to go over this one in detail because it's kind of an interesting scenario. You now have a real problem here. You guys know what's the problem? You can't zero any of the other terms out, can you? We can't zero any more terms out. So if you're in that situation, and I want to make sure, you could use any x value now. I'm going to say use an x value equal to, I use 2. But we can use any x value. You're not going to get anything zeroed out, though. But let's see what you get, right? If x is 2, put a 2, put a 2. Wherever there's an x, you put a 2 here. And again, that means on the left side, you got 1. And I think that's going to be just 2a. Double check, ladies and gentlemen. Plus ab. Plus 2 squared, 4c, plus 4d, ladies and gentlemen. Okay? But then you might say, but Mr. Judge, what do I do with this information now? Well, you know what B is, and you know what D is. They're both what? They're 1. So you get 1 equals 2a plus 1 plus 4c plus 4, because 4 times 1. And I'm going to say you get 1 equals what? 2a plus 4c plus 5. You get 2a plus 4c is negative 4. Divide everything by 2. You get a plus 2c equals negative 2. I'm going to highlight this equation here. Okay? So what do you think will happen now? You say, Mr. Judge, you guys see any way we can get these values? You know what you may have to do? I'm going to let x be another number here. Let's try x being, what number should we try? Should we try 3? Okay. You guys will see my point. If x is 3 now, I get 1 is 3a, x is 3. 3 minus 1 is 2, 2 squared is 4. Okay, x is what again? 3. 3 minus 1, isn't that 2? 2 squared is 4. X is 3. 9, what's 9 times 2? Is that 18? Oh man, plus 18c. Okay. X is 3. Oh, plus 90. Double check I don't make a mistake. And then 4 times 3 is 12. This would be 12a. Now, what do you think you guys want to do again? Let B what? Be 1 and let D be 1. Do you guys know why? Why do you want to let those things be 1, B and D? What you're going to get now here, if these things are 1, you're going to get another equation in terms of A and C. 1 is 12A plus 4 plus 18C plus 9. 12A plus 18C. What's 9 plus 4? Isn't that 13? Subtract 13. Negative 12 is what? 12A plus 18C. Can I divide both sides by 6? I get negative 2 is 2A plus 3c, or I can say 2a plus 3c is negative 2. Okay, you guys okay with that? So what does this mean, ladies and gentlemen? You guys know what this means? What does this actually mean? What are you guys looking at? As I try to log in this computer. What do you guys do? How do you get A and C? Yeah, 2 equations, 2 unknowns. Go back to beginning algebra. You say, what are you talking about? Can I solve this by the substitution method, right? I can say, you know what? A is going to be what? Negative 2 minus 2c. So I can replace my A with what? Negative 2 minus 2c. Is that true? Negative 2 minus 2c. So, ladies and gentlemen, you get 2 times negative 2 minus 2c plus 3c is negative 2. Negative 4 minus 4c plus 3c is negative 2. Negative 4 minus c is negative 2. And I can translate my terms. So negative 4 plus 2 is c. What do we know? C has to be what number then? Negative 2. And if C is negative 2, okay, if C is negative 2, plug in negative 2 for C. What do you guys get for A? A is negative 2 plus 2. Is that true? Double check. C is negative 2. Okay. A will be negative 2 plus 4. I apologize. My arithmetic is off. Negative 2 plus 4. What does it mean about A then? Then A has to be what? 2. Anyway. So, ladies and gentlemen, yes, if you don't get enough zeroing out, okay, if you can't zero enough terms out, then just use different values of x and use the a and b values, whatever you got, and create additional equations to solve. This is solved by beginning algebra. So now we have all the values, right? And you say, well, what are these values good for? Well, A, what was A? 2. What was B? 1. D was 1. And my C was negative 2. That's what I remember. So now you have a much easier what? In theory, you have a much easier integration to do. A is gone, B, C, D. So here's what that means. 2 over x, 1 over x squared, pull out your constant, 2. Properties of integrals. Oops, this is a dx. these again, what I'm saying is you have to integrate, this is going to be what by what? By u sub, and this is by what? U sub, where u is x minus 1, du will be dx, okay? So here's what you guys will get as a final answer for this one. Okay, you're going to get finally what? 2 natural log absolute value of x minus 1 over x minus 2 natural log absolute value x minus 1 over x minus 1 plus c. All right, so double check, ladies and gentlemen. Double check that that's what you get for this repeat linear what? Factor. Okay, by this integration here. Okay. So we're going to look at what you have when you now have a quadratic factor. Quadratic factor is a factor that looks like this, ax squared plus bx plus c. Okay, so the example I have here to start us off for a quadratic factor is x squared minus x plus 6 over, we'll put x cubed plus 3x dx. So remember what you always have to do with the denominator here. You got to factor it out. And the only term you can factor out is an x. You're left with x squared plus 3 here. Okay? That here, you can't factor further. This is a linear factor, but they now introduce to you what? A quadratic factor. And notice that quadratic factor is not what? The quadratic factor is not repeated. You guys see what I'm saying? It's just first power. So we're going to share with you guys first, okay, what do you guys do with the quadratic factor? And then what do you guys do when the quadratic factor is repeated? That's the idea. All right. So here's what you guys are going to use, right? For every quadratic factor, you're going to use, this is over the quadratic factor, ax squared plus bx plus c. Here's what I'm going to say to you guys. What if the power is 2? This is how we know it's a quadratic factor, in case you guys didn't know. Okay? And I'm not going to use that color. I don't know, pink maybe? 2. Oh, it looks like this is the same color. Okay. That's how you guys know it's a quadratic factor. Highest power is 2. And you can't break it down. You can't factor it further. So now, here's the deal. The top term is a linear term. So for every quadratic factor, in this question there's only one, you're going to use what? This ax plus b. And you're going to have to find the values of a and the value of b. So you might say, well, how does that work in this case? Well, in this case, notice you have what? You got the x squared, ladies and gentlemen, minus x plus 6 over, you have this x squared plus 3. So let's be careful. That's a linear factor. So I have to use what? A over x. So far, so good. I now have to think about what to use for the what? For the quadratic factor. And you say, what do I do there? Well, you put the This is not repeated, so you have an x squared plus 3. That's good. But then I have to have a linear numerator. You already choose the letter what? A, is that right? So what do I do? You go, but you told me to use ax plus b. Do I use a again? No. What's the next letter? You're going to do bx plus c, okay? So that's what you're going to have to do if you have a quadratic factor. I know they gave it to you this way, but if a is already used, go to the next letter, capital letter, and use bx plus c. Okay? And then you say, well, what do I do now? Well, on the right-hand side, you add. So you now get a x squared plus 3 plus, what is this? Is that x? Bx plus c over x squared plus 3. So again, we have equal fractions, the same denominator. Here's what that means. You get what? X squared minus x plus c will be a x squared plus 3 plus x bx plus c. Okay, you guys okay with this? We need to find the constants A, B, and C. So here's what I'm going to say to you guys. How do you think you should start this off? You have a problem right in here, don't you? You can't zero that out. You got x squared plus 3. There's no way to zero that out, is there? Is there a way to zero this out? Yes. How do you zero that out? Well, let x be 0, so I replace a 0 wherever there's an x. Oh, you go, okay, this is 0. Yes, it is. So in x is 0, we get 0 squared minus 0. Isn't that just 6? So 6 will be 0 squared, that's 3a. That means a equals what? 2. Now, that doesn't help me much. But I want you guys to note something here, okay? I'm going to share with you guys something very powerful here. Note what you had to begin with. X squared minus x plus 6 equals, I'm going to do some algebra. Okay? That's ax squared plus 3a. And then that's what? Plus bx squared plus cx. On the right side, what that means is x squared minus x plus c is a plus b with the x squared term plus cx plus 3a. Okay? This is a very powerful approach. In fact, when I took this course years ago, when I was your age, this is the preferred method. It was not all these cases that we did here. You know, this is what we had to do when I took the course. And then you said, Mr. Judge, what do you mean by that? Okay, remember, your left side equals your right side. Is that true? So focus on this. A plus b times x squared, you know what your a value has to be? Or I'm sorry, you know that number here? That x squared on the left, the constant's 1. You know what that means? A plus b is 1. And then you said, but what does that mean over here with the x term? You see the constant c here? What constant's in front over here? -1? You know that means c is -1. I got a c value. Nice. And in fact, at the very end, you might say, does that mean my constant 3a has to be 6? Because the left-hand side equals the right-hand side? And I'll say yes, 3a is 6. That means a is 2. We already know that. But if a is 2 now, what does that mean about b? 2 plus b is 1. Subtract 2. What does that mean about b? b is what? b is -1, ladies and gentlemen. Easy peasy lemon squeezy. So what I'm saying here is this. Another approach is to use algebra here. And then you equate the constants on the left with the constants on the right. Okay, and now we say, okay, a was 2, so go back over here. A is what? 2. And you said, okay, what was b? -1. Okay, and then what was c? -1. Okay, what was that fraction? Copy. What is this by partial fraction decomposition? You're going to integrate 2 over x minus x plus 1 over x squared plus 3 dx. You said, why? Because this is going to be -1 and this is going to be -1. All I did was factor out the -1 here. Now, you might say, well, what does this become? Well, this is the integral of 1 over x minus, well, what? X squared plus 3. That's -1 x squared plus 3 dx. Double check by your algebra there. And that's not right. Let me do this here. That's not right. There's a dx. Dx, integral dx. Well, it's not going to be plus because you factor out the negative. Right? You factored out that negative here. That negative is at the same level when you factor it out. Okay, and then I make the claim you guys can integrate all of these here. That integral, this is a u sub. Do you guys recognize the last integral? I make the claim you should. What is this? The last integral, final answer, 2 natural log absolute value of x, and then by u sub, 1/2 natural log x squared plus 3, 1 over the square root of 3, inverse what? Tangent of what? X over the square root of 3 plus c. Okay, you guys see that there? Now I'm gonna put the video up online. However, you do have homework in Canvas on partial fraction decomposition integrals. And what else I want to say, we're going to do some more PFD tomorrow. Tomorrow's Thursday. We'll do more PFD, partial fraction decomposition. We'll look at some other examples of, now repeat quadratic and so on. And you'll see how to do more of these. But anyway, ladies and gentlemen, try this out. And we'll see you guys when? Tomorrow, your homework's in Canvas.